and welcome back to Crunch Math. Today we're going to be going over the third section of the SAT Math, problem solving and data analysis. These are 5 of the topics: ratios, rates, proportional relationships and units, percentages, 1 variable data distributions and measures of center and spread, 2 variable data, models and scatter plots, probability and conditional probability. Then there's actually 2 more, which are inferences from margin of error and evaluating statistical claims. Now, what we're going to see is the bulk of what you're going to see on the SAT is going to be these first 5 ones. The other ones are more dealing with some logical ideas and just understanding different things like mean, median, and standard deviation. Now, before we get into some practice problems, let's go over some of the things you will see. Just remember, a ratio you can see as a fraction or with these two, with a colon, with one value right here and then another value right there. And it's usually used for different comparisons. And then you can formulate rates from those, like miles over seconds, for example. Percentages, just mainly know the symbol. And then something you need to know too is how to convert those to decimals. Let's say you have 100%. That's to be the same as the number 1. Let's say you have 35%. That's going to be the same as 0.35. And then if you have, let's say, 6%, that's going to be the same as 0.06. So this is how you represent different percentages, where 100 is 1, so meaning like 200 would be 2 then. If you have things in the tenths digits, like 35, 65, 75, then it's going to be a point and then those 2 numbers. But if you have a singular digit like 6, 1, it's going to be 0.0 and then that number. And then so on and so forth. And then just learn how percentages work. If something is 40% of what it used to be, that means it's decreasing by 60%, vice versa. Now, distributions and measures of center spread, just remember mean, median, and mode. Mean is your average, where you're first going to add up all your things, and then you're going to divide by the number. That's basically all, by the amount there is. That's basically all your mean is. Your median is the middle. So when you take all your values, let's say you have a bunch of values on the number line, whichever one is in the middle number, that's your median. And then so you have mean, median, mode. The mode is the one you see the most. So let's say you have again your number line, and let's say you see a bunch of numbers right here. They're all the same numbers. That's gonna be your mode, that's the most there is. And then the range is just gonna be the difference between your starting value and your ending value, in which then you can have graphs with it. Let's scroll down. Let's say you have some sort of graph right here. You have something right here over something right here. You can have a bunch of values right here, a bunch of values right here. And let's say these are imagine there's a bunch of dots. Like this. Now your standard deviation, you're going to see it deviates to over here because that's where a majority of your things are. That's basically what standard deviation is, and which you're just trying to see where the data tends to lean towards. Does it lean towards the right, left, or does it lean towards the middle? Now, another thing I want to go over is something called, it's some box chart. I forgot the exact name. But let's say you have your number line with a bunch of your values, right? Then you can also see that there's something above it. And you see this box. And then you're going to see a line through this middle box. All this is, it represents different, not quadrants, but like sections. This is your first section. This is your second section. This is your third. This is your fourth. Which means that this first line right here, this is going to be your first value. And this one right here is going to be your second. It's going to be your last value. What this tells us is then we can find range from this box. And then the middle line is going to be your median. Not your mean, your median. This is something the SAT will for sure ask you. And that's scatter plots. say you have a dice, you roll it, and let's see what's the probability that it lands on 5. The die has 6 faces, there's just a 1 out of 6 probability. And then you'll see how you can dwindle that down over time with different events and occurrences. We'll go over that. Inferences from sample statistics and margin of error. Sample statistics, let's say you have a group of high schoolers and you want to survey them, so you take 40. That's going to be your sample. Now, your largest sample you take is just all of those people, but obviously that's going to take time. Your margin of error, it's usually, let's say, it'll say 20% of people will do this, but there's a margin of error of 2%. What this means is that this 20% estimate of, 20% of people do this can be off by 2%, meaning it can range between 18% and then also 22%. It's this plus minus. Plus minus is the main thing to know for your margin of error. Now, then the other ones are just claims which tie in everything together, like mean, median, standard deviation. That's all it is. All right. The expression 0.35x represents the result of decreasing a positive quantity x by what percent? I'll give you all a second to look over this. Now let's go through this. First, you have this expression, 0.35x, and we know it's decreasing. So x is our original value, and what this 0.35 is telling us is that it's going to be 35% of its original amount. So we're converting this decimal into a percent. So meaning this x value is 35% of what it used to be after every certain amount. But that doesn't mean our answer is going to be B or A. Because if something's 35% of what it used to be, you're subtracting 65% from it. Meaning our answer is going to be D. The reason C and A are wrong is you're not going to get something like that because that means you messed up converting this number into a percent. You messed up something like that. Just remember what we went over. Okay, now let's go over this. I'll give you a second to read. Seems like a lot of numbers. Let's skip the first part. Let's not look at the graph. Let's just read what it's saying. This is one of those last 2 units where you're taking something based on marginal error or just something looking at the statistics and trying to deduce something. So let's look at this. Let's just look at the question. The question starts right here. Based on the data from the study, an estimate of the percent of US teens who are heavy texters is 30%, with a margin of error of 3%. So you have to add in this plus minus 3% to that 30%. All right, which of the following is a correct statement based on the given margin of error? Approximately 3% of teens are heavy textures who are classified as heavy textures are not really heavy textures. That's not what it's saying. We're saying that of this 30%, maybe it can be 33% more are heavy textures or 3% less. But it's not saying 3% aren't. That's not how margin of error works. B says it's not possible that the percent of US teens who are heavy textures is less than 27%. It's not possible that, well, let's see. 27%, if we take the lowest, are heavy textures. Now, this may be an answer choice, but let's keep looking. C says the percent of all US teens who are heavy textures is 33%. No, it lies between a range of 27 and 33. So it's somewhere between that. It's not going to be C. D says it is doubtful that percentage of US teens who are heavy textures is 35%. So now we're between B and D because these both relate back to the margin of error. But B is going to be wrong. The reason B is going to be wrong is that it technically is possible that it can be less than 20% over time. Over time, that can possibly happen. Now, D is correct because our margin of error says that this percent of heavy textures lies between 27 and 33%. So it's not likely. It's not saying it's not possible, but it's doubtful. It's not likely that the heavy texture is going to be 35%, meaning our answer is going to be D. All right, now we're going to have this problem. Pause to read this, and then I'll go over it. Okay, so A is 2,241% of the sum of B and C. So let's just make it a quick equation where A equals, we're going to convert this percent into a normal number, which is me 22.41. And then this is times the sum of B and C. So now we have this equation here. Now, we also have this other bit of information where B is 83% of C, meaning we're just going to see B equals 0.83 of C. And we just converted that 83% into a normal number. So now if we plug B in terms of C, we're going to see that 1.83 C times 22.41 equals A. Using Desmos, we can multiply these two numbers together, in which then you're going to see A equals 41.0103 C. Now, what we're then going to do is we know B equals 0.83 C, meaning that C is going to equal to B over 0.83. So we're just going to plug in C in terms of B. So instead of C, it's going to be B over 0.83. And then we're just going to do 41.0103 divided by 0.83. In which then you're going to see A is going to be 49.41 of B. Now, what we can do with this information is we just need to convert this 49.41 into a percent, which should be 4,941. And our answer is just going to be D. All right, let's go on to the next problem. All right, I'll give you a second to read and look over this graph, and then we can go over it. So we have this scatter plot, and what you're going to see is this is a decreasing exponential function. It's decreasing, and we're given this equation, and we're looking for what B is. Now, in this exponential equation, B is basically our rate. Don't look at A. A doesn't matter as much. That's just our initial value. But B is going to be our rate. So what is this decreasing by? In order for some exponential to decrease, so that rate must be less than 1. Meaning you can go through each of these points and figure out the percent difference, but let's just look at the answers. A is a possible answer because that's less than 1. B isn't less than 1. C isn't less than 1, and D isn't less than 1. B, C, and D are all meaning that this is going to be increasing exponentially like this. But A shows us that it's going to be decreasing like that, meaning A is going to be our answer. All right. This one deals with probability, so I'll give you all a second to read, look over this, and then we can do it. Paused and looked over it. Now let's actually do it. A grove has 6 rows of birch trees and 5 rows of maple trees. Then we have a bunch of information. Well, let's look at the question. What is the probability of selecting a maple tree given that the tree is 20 feet or taller? So out of all these rows, we're taking just one singular tree and then deducing if it's a maple tree and 20 feet or taller. So first, let's actually figure out how many trees are there in total. We have 6 rows of birch. There's 8 trees 20 feet or taller and 6 trees that are shorter than 20 feet. Meaning that in each row, there is going to be 14 trees. So just 14 times 6. You can use Desmos, but that's just going to be 84. That's from the rows of birch trees. Then we have 5 rows of maple trees. 9 are 20 feet or taller, and 7 of them are shorter than 20 feet. So it's just going to be 5 times 9 plus 7 is just 16. 5 times 16, which is just going to equal 80. And then we just add these two together, and we see that there's 164 trees total. I'll just keep this in mind. It may come useful because we can see now maybe A is a possible answer. But now let's see how many of these trees are 20 feet or taller, because that's what the two have in common. So maybe this 164 is useless, but let's see. We see out of the 6 rows of birch trees, 8 of them are 20 feet or taller. So 6 times 8 is just going to be 48. Then we also have to add which ones are taller from the 5 rows of maple, which would be 5 times 9, which is just 45. So you add 48 plus 45, that's just 93. Meaning 93 of the trees are 20 feet or taller. So actually this 164 was useless. And that's okay. That's something you need to learn. You may find useless information, but it's okay. You're still learning more about the problem. So 93 of these trees are 20 feet or taller. Now, how many of these would be maple trees? We know that's just 5 times 9, which is just 45. And then from here, it's just simplification. These have 3 in common. So it should be 1, 5. And then divide this by 3. That's just 31. Which our answer is then just going to be C. Now you got a few more left. Okay. I'll give you a second to pause and read this question. Then let's go over it. The mean score of 8 players in basketball was 14.5 points. If you remove the highest individual, then it becomes 7. So let's see. So we have some score here divided by 8 equals 14.5 points. So let's figure out the score. The score, if we just multiply 14.5 by 8. Let's do that right now. You're going to see that the score is going to be 116. Then when you remove your player, you have the second score, S2, divided by 7 equals 12. So now you just multiply 7 times 12, and we're going to see our score 2 is going to be equal to 84. Right? And then you just have to find the difference between these scores. So 116 minus 84. And our answer is just going to be 32. So that was a quick, easy mean one. That's just by doing mean, using the mean equation. Now let's go on to the next problem. I'll give you a second to pause and read this, then let's go over it. Read it, let's see. We have initial deposit of X, and it doubles each year. And the difference in years is from 2001 to 2004. So we have a 4-year gap. So our money doubled for 4 years. And by the end, we have 480. And we're looking for our initial deposit. So we're just going to divide 480 divided by 2. We're just going to do this 4 times. Divided by 2, 240. Divided by 2, 120. Divided by 2, 60. And then just divide it by 2 one more time, and you'll get 30. Meaning 30 is x, and that's our answer. Now, I know what you're thinking. Some of these problems are super, super easy. But here's what you need to know. These all come from the hard difficulty of the SAT math section, meaning some of the hard problems may even be free to you. And that's good, which is why you cannot get them wrong. You cannot. Oh, here's the box plots. So I'll give you a second to read, look over it, and then let's go over it. So after you looked over it, let's look. We're looking for the difference between the ranges. So we're going to take the range of each one and find the difference. Let's look at A. We're going to take the range between the starting and this ending value, which is from 0 and 5. So this range is 5. Class B's range starts at 1, ends at 10, meaning this is going to have a range of 9. And so it's just 9 minus 5 to get that positive difference, and that's just going to be 4. And that's our answer. Super simple. The hardest part about this is just understanding how box plots work, which is at the beginning of the video. Alright. Now let's go over this one. I'll give you a second to pause and read over this, then let's go over it. Hopefully attempted. Let's look at this. The dot plot represents a data set of number of bursts for 13 eruptions. If an additional 11 bursts added to the set to create a new data set of 14 eruptions, which of the following measures will be greater for the new data set? Alright. So we're having 11 new eruptions. To create a new data set of 14 eruptions. Hold on. Okay, so which ones will be greater? So we have 13 eruptions right here, and 11 bursts happen. Oh, okay. Now you're adding another eruption with 11 bursts. So you're going to see is that somewhere over here for one eruption, there's going to be one with 11 bursts. Now, which of these will be greater? Now, let's look at this. The median is our middle. So let's look at this. Originally, our median, let's keep subtracting. One right here, one right here. One there, one there, one there, one there, one there, one there. And which our median is just going to be at 2. I mean, even if we just add another one, the median is still going to be in this 2 range. So it can't be 1. So it can't be A, B, or D. Or actually, it may be D. Sorry. Because we don't know if 2 is correct. Now let's look at the median. The median, now we have a huge skew to the right. Meaning for sure, even if you divide it by another burst, this burst is so much greater than all of these. It's going to skew the data that way, and our mean is going to increase by a lot. Meaning our answer is just going to be C. Okay, let's go on to our last one. Okay, I'll give you a second to pause, read, and look over these dot plots, then we'll go over it. Paused and looked over it. Let's look at this. So we want to look at what's true. Our first claim is the median of data set A is equal to the median of data set B. Let's just look over this. Let's look at our medians. Well, just by symmetry, you can see on data set A, both are going to cancel out if you keep crossing out 1 from each side, and our median to be 13. By symmetry on dot plot 2, or data set B, by symmetry, these are all going to cancel out, and the middle is just going to be 3. So A is correct, meaning it can't be B and it's not going to be D. We're left with either A or C. Now let's look at the standard deviation. Let's clear this up a little bit so you guys can see. Standard deviation, they're saying they're equal. Let's see if this claim's true. If we look at data set A, we see that our scores, if we make it draw like a curve, our standard deviation is more evenly spread out. It's more even. But if we look at this standard deviation, you have 2 peaks. Our standard deviation tells us that our answers deviate towards the endpoints, meaning these are not going to be equal deviations. These graphs are 2 very different things, which our answer is then just going to be A. And I'm pretty sure that's the last one we have. This is our quick crash course, basically, over a bunch of problems for problem solving and data analysis. I hope that this was helpful to all of y'all, and y'all learned some tricks about probability, percentages, dot plots, bot plots, scatter plots, ratios, and I hope this helps you ace your SAT. Thank you for your time, and thank you from Crunch Math. Thank you.